In our last pair of examples, we want to identify the behavior of these rational functions. Specifically, we want to identify the local and end behavior. While we're using different language to refer to some of the same ideas, we want to make sure we're building those connections in our head. When we talk about local behavior, what we want to focus on are vertical asymptotes. And when we talk about end behavior, we want to focus on the idea of any horizontal asymptotes, or what's happening at the extreme values of x. For part A, we can trace along our curve around x equals 2 to see what the behavior of our curve looks like. We can see that as we approach from the right, we're headed to positive infinity. As we approach from the left, we're headed down to negative infinity. So we could say that as x approaches 2 from the right, our function f of x, let's label this f of x so we can reference it that way, our function values are approaching positive infinity. And then as x approaches 2 from the left, f of x is approaching negative infinity. Where again that plus indicates that idea of approaching that asymptote from the right-hand side. The minus sign indicates that we're approaching from the left-hand side. And then just reading that behavior. To discuss the end behavior, we'll trace along our curve and look at what's happening as x is getting larger and larger, and what's happening as x is getting smaller and smaller. In this case, we can see that as x is approaching infinity, f of x is approaching 3, and as x is approaching negative infinity, f of x is approaching 3. Those two statements describe the end behavior of the function, and since the results ended up being numbers, in this case 3 on both ends, we would say that we have a horizontal asymptote. At y equals 3, or of, I should say, y equals 3. That's the relationship between horizontal asymptotes and describing end behavior. If the end behavior leads us to a number, then we have a horizontal asymptote. In example 6, we want to repeat that process, but with a different function, which we'll refer to as g of x. First, we want to describe the local behavior of the function. We have a vertical asymptote at x equals 1, so we can trace along the curve as we approach from the right, and trace as we approach from the left. In both cases, as x approaches 1 from the right, our function g of x is headed to negative infinity, and as x approaches 1 from the left, g of x is also headed to negative infinity. When we talk about the end behavior, again, we're looking at what happens as we trace along the curve towards larger and larger values of x and towards smaller and smaller values of x. In this case, it's implied that that curve just keeps going in the direction that we see. So we can say that as x approaches positive infinity, g of x is approaching negative infinity. And as x is approaching negative infinity, g of x is, again, approaching negative infinity. In this case, the end behaviors lead to negative infinity. If they lead to positive or negative infinity, that means there is no horizontal asymptote. A horizontal asymptote only exists if we get a numerical value for that end behavior. A couple of notes just to add some clarification to some of the different variations you might see here. Local behavior, so the behavior around a vertical asymptote, can be the same or different on each side. We've seen examples of both of those cases. Our function can curve in the same direction or in opposite directions. End behavior can be the same or different. It could head to negative infinity on one side, positive infinity on the other. It could both be headed to positive infinity. One end could have a number value, the other could be to infinity. But again, anytime we get a number value, that indicates that a horizontal asymptote exists. And anytime we get either positive or negative infinity, that indicates no horizontal asymptote, at least on that end of the graph.